In this example, we're going to calculate the correlation coefficient R for this small data set. So typically we would want to use software to calculate the correlation, as it's pretty tedious. But for a small data set, we can still show how we can calculate it by hand. So R is equal to 1 over n minus 1 times the summation of each observation of x minus its mean divided by the standard deviation of x times its paired value of y minus the average of y divided by the standard deviation of y. So we can actually rewrite this expression as R equal to 1 over n minus 1 times 1 over sx times sy. And why we want to do that is because that way we don't have to divide by each standard deviation when we carry through the sum. Because these aren't associated with the the index, we can actually just pull them out. So the summation of xi minus x bar times yi minus y bar. So this is an equivalent statement. It's just going to be a little bit easier to calculate. Okay, so n in our problem is equal to 4. There are 4 observations or 4 pairs of x and y data. And the first thing we want to do is we need to calculate the mean of x, the mean of y, and the standard deviations of both. So we can calculate these using simple methods of adding these up, dividing by the total of them. So the mean of x bar is equal to 2. We find the mean of y is equal to, so y bar is equal to 4.5, the average of y. And the standard deviation of each can just be simply calculated by the square root of the sum of each observation minus the mean squared divided by n minus 1. So the total number of observations minus 1. This will be the standard deviation, and we can use this formula to calculate the standard deviation of each group. So I already did this, and that is equal to 0.816, and the standard deviation of y is equal to 1.291. All right, now we can use these values to calculate our correlation coefficient. So R is equal to 1 over 4 minus 1, which is equal to 3, times the standard deviation of x, which is going to be 0.816, times the standard deviation of y, 1.291. And we need to multiply this by then each expression minus its mean times its paired value minus the mean of the pairs. So in this example, the first observation is 1 and 3. So that's the first pair. And so we know that that's going to be 1 minus the mean of 2 for the x's times its paired value of y of 3 minus the mean for the y's, which is 4.5. And then we need to add on the next one. So x is equal to 2 minus the mean of 2 times then its paired value of 4 minus the mean of the y's, which is 4.5. Now add on the next observation, and I get 2 minus 2. So the observation for x is 2 minus the mean of 2 times the y paired value of 5 minus its mean of 4.5, plus the last observation, which is 3 and 6. So x is equal to 3. The mean is 2 times the paired observation for y, which is 6, minus the mean of the y's, which is 4.5. All right, so what I get from this then, R is equal to 1 times, and let's go ahead and multiply these things together. So 3 times 0.816 times 1.291 is equal to 3.16. And this is then times what we get from over here, which 1 minus 2 is negative 1. Negative 1 times 3 minus 4.5 is negative 1.5. Plus, this would be 0. 2 minus 2 is 0 times 4 minus 4.5, which is a negative 0.5. Plus 2 minus 2 is again 0 times 4 minus 4.5, which is a positive 0.5. Plus the last expression here, which is 1 times 6 minus 4.5, so 1 times 1.5. All right, so adding those all together, we get 1 over 3.16 is multiplied by negative 1 times 1.5, which is equal to 1.5, plus 0, plus another 0, plus 1.5. So R is equal to 1 over 3.16 times 3 which is equal to 0.949. So this is a really large correlation. So this is a strong relationship. Recall that our correlation coefficient goes from -1 to +1, and the further it gets away from 0, the stronger the relationship. And the closer it is to 0, it's weak. So this is 0.95 essentially, and that's a very strong relationship. So there's a strong relationship between x and y in this example with just a couple of observations. All right, so again, we typically use software to calculate the correlation coefficient, but this is a simple way that we can also calculate it by hand.